Hello, this is Mr. Cerisa, and today we'll go over the introduction of the hyperbola. So the hyperbola and the ellipse are actually very similar, even though they look completely different. I have the picture of the hyperbola right here, and but the ellipse looks very similar, especially if you look at their equations. And so you have the equation here, we have the x squared over a squared minus y squared over b squared equals 1. They look really similar, but the one big difference is that subtraction there. And so that subtraction goes along with the definition where the distance from a foci to a point to the other foci will have a constant difference. So let me just kind of draw in a couple of foci here, and you'll see what I mean. So let me just put in these foci. And if I just took one foci to a point, and then subtracted it from this distance, that should be exactly the same as any other distance to the other foci. So I go from distance to the foci, all of these will end up being exactly the same. So other similarities, here of course I just mentioned these. There's foci in the hyperbola as well. There's also vertices, and you could probably guess where the vertices are. Right here and here. So those are the vertices. And one thing is kind of similar, but they give it a different name. Instead of a major axis, what they call here the axis that goes through is the transverse axis. So new name, but it really means the same thing. Oops. Transverse axis. And then they also have the conjugate axis would be the other one, and they meet right in the middle, of course, at the center. And so all these terms sound very similar, and they seem like they should be really similar, and they are, but there are slight differences in the calculation. So with hyperbolas, this time we have, oops, I just realized I left off the squared term here. So a squared and b squared there. The difference is here b squared equals c squared minus a squared. And then also, of course, a squared equals c squared minus b squared. So this feels a lot more like the Pythagorean theorem, because if you rearranged it, you'd see a squared plus b squared equals c squared. I don't know if that helps or not, but it is different than the ellipse, so make sure that you know which one goes with which. Similar, of course, the center to the vertex is A, and the center to the foci is still C. The B is used when we graph it, and I'll go over that when we start graphing those. And then finally, the last similarity is going to be we can always shift this around and have a new center at HK. So don't forget that. And this shifting is still the same. You just shift everything up H, or over H, and then up K. Okay, here's your introduction to a hyperbola. I hope that this helped. Thanks.